Okay, so what else is the mole equal to? The mole is actually equal to other things. So far we know that the mole is equal to the molar mass in grams. Okay, now 1 mole is also equal to 22.414 liters of a gas. Okay, so we can use this knowledge and this knowledge to solve problems now. So let's look at one. Okay, how many liters are in 2.4 moles of HCl? All right, well, we got 2.4 moles. All right, and then remember we have 2 conversion factors so far. Okay, so 1 mole is equal to the molar mass, and 1 mole is equal to 22.414 liters of a gas. Okay, so we know mole is going to have to go on the bottom. And from our conversion factor, all we have is 1 mole, right? Okay, so we know it's going to be 1 mole there. Now we're trying to find how many liters. So we're going to have to use this conversion factor to get to liters. So we've got 22.414 liters. All right, and our mole unit cancels, so we got 2.4 times 22.414. Okay, so I got 53.79. And the unit's liters. Now, of course, let's go back in sig fig. So 2, there's our first 2 significant. The 7 going to make 3 round up or stay the same. It's going to round up, so you got 54 liters. Okay? All right, let's look at another one. All right, how many moles are in 29.5 liters of H2 gas? All right, you got 29.5 liters. Okay, now remember the conversion factors. Probably should have just wrote this on the slide so that I don't have to write it over every time, but it's okay. All right, 22.414 liters. Wow, it's a 4. Okay. All right, so you have liters here. So you have to have liters on the bottom. So that's going to be this, our 22.414, because that's the only liters we have in the conversion factor. And that's equal to 1 mole. Okay, so you can cross out liters. So you get 29.5 divided by 22.414. All right, so 29.5 divided by 22.414, 1.316. And the unit's mole, right? All right, now let's sig fig. We got 3 here. There are our first 3 significant. So 6 is going to make it round up or stay the same. It's going to make it round up, so 1.32 moles. Okay? Now at this point you're probably going, I know that can't be it. You're right, it's not it. The mole is equal to one other thing. So far, our mole is equal to the molar mass in grams, and it's equal to 22.414 liters of gas, and it's also equal to 6.02 times 10 to the 23rd particles. You're probably thinking, wow, that's a lot. It is a lot. Okay? Now, particles is a broad term. It's kind of like fruit. Okay? But there are other more specific things that can fall under particles. Those are atoms, ions, molecules, and formula units. Okay, So, particles is like the broad term, and then atoms, ions, molecules, and formula units are more specific. So particles is kind of like me saying fruit, and then atoms, ions, molecules, and formula units being specific fruits, like strawberries, apples, bananas, and grapes. Okay? So if you see any of these words, you understand that it really means particles. All right, let's look at a problem. All right, it says how many atoms are in 0.74 moles of CO2? All right, we got 0.74 moles. All right, let me throw our little conversion factors right up here real quick. That's the times. Okay, so mole goes on the bottom to cancel. It's always going to be 1 mole. At least at this point in your chemistry life it will be. All right, we're trying to find atoms. Now, atoms are the same as particles. So we're going to use that lovely number, 6.02 times 10 to the 23rd. All right, so now you want to plug that big old bad boy in the calculator. All right, I always use parentheses whenever I'm dealing with scientific notation numbers. Okay, all right, we're going to hit equal. All right, so we got 4 point blah, 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 a whole bunch of numbers, right? All right, so we're obviously going to have to write this one in scientific notation, my friends. Your calculator might give it to you in scientific notation. My little calculator on the computer does not, so we will have to convert it ourselves. So we know we're going to need 2 sig figs, so 4.5 times 10, and then we got to count all these little things over here. So let's go ahead and count. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So that should be 4.5 times 10 to the 23rd particles. Or you could have wrote atoms. That would have worked too. Ooh, that's fun, right? All right, let's do one more problem. Okay, so this one it says how many moles are in 8.3 times 10 to the 19th molecules of KAlSO4. All right, so you got 8.3 times 10 to the 19th molecules. Now looking at your conversion factors, molecules are the same as particles, right? So you got to put your 6.02 times 10 to the 23rd molecules on the bottom. Okay, and that's equal to 1 mole. All right, molecules went away. Now it's just all about the calculator. Don't forget parentheses on everything that's a number in scientific notation. Okay, so we got 8.3 times 10 to the 19th. All right, and that's going to be divided by 6.02 times 10 to the 23rd. All right, now equals. All right, so we got 1.378 times 10 to the negative fourth. So that little e, when you see it on your calculator, it means negative 4, or e means times 10. Okay, and any number after it is like the exponent. Okay, all right, so we got a sig fig, so we're going to need 2 sig figs, so 1.4. Okay, times 10 to the negative fourth, and your unit's moles. All right, so that concludes this podcast. Please write down any questions you may have for me, and we'll work on this during class. See you then.